In this video, we will work through some examples of converting units from one unit of measurement to another. To help us, we will consider basic algebra to ensure we convert correctly. So in this basic example, we are asked to convert meters to feet. So we'll begin by noting the conversion factor from meters to feet. And 1 meter is equal to 3.2808 feet. So we could write it out like 1 meter is equal to 3.2808 feet, or we could write 1 foot is equal to however many meters as well. Either case is fine. So then we write down 6.251 meters, and now we're going to multiply. So we have to decide in terms of this conversion factor, we need to divide one side by the other. So that way we're left with 1 on the other side. So if I were to divide both sides, for example, by meters, well, dividing this by 1 meters gives us just 1 left over here, and 1 meter dividing by 1 meter gives us this. So essentially, this would be our multiply. This would be what we multiply our value by to obtain a different unit. So if we do that in this case, 3.2808 feet divided by 1 meter, well, here you can see that the meter cancels out, and then we're just left with feet. And now all we have to do is just simply multiply 6.251 by 3.2808, which gives us 20.508 feet. In this second example, we're asked to convert 8.340 pounds to grams. So again, a similar circumstance as before. And so we'll again approach this by writing down the conversion factor from pounds to grams. So 1 pound is equal to 453.952 grams. And then we write 8.340 pounds. So we're trying to get rid of the pounds. So again, we're going to look over here and we're going to multiply our pounds by either 1 pound divided by 453.952 grams, or 8.340 pounds multiplied by 453.952 grams divided by 1 pound. Which one we choose is dependent on what units we wish to end up with. So we wish to cancel out the pounds and replace it with grams. So what I'll do is I'll multiply by 453.952 grams divided by 1 pound. And so the pounds cancel out, and then we simply multiply the two numbers together, and that gives us 3783 grams. In this example, we're asked to convert feet per hour to meters per second. So we'll have to consider 2 unit conversions in order to do that. So the first unit conversion is 1 foot, which is equal to 0.3048 meters. The second conversion is, of course, 1 hour, which is equal to 3,600 seconds. Now, 3,600 seconds, the way that we obtain that is 60 minutes multiplied by 60 seconds. Then again, we write down our quantity that is to be converted. And again, in this instance, I will now present the units as a fraction, and that just makes it easier for ourselves to algebraically cancel some of the terms. So first of all, I want to get rid of the feet and replace it with meters. So the way I would do that is multiply it by 0.3048 meters divided by 1 foot. And then, of course, our feet will cancel out. So that's good. And then again, now we're trying to get rid of, in this time, we're trying to get rid of the hours and replace it with seconds. So I would like my seconds to be at the bottom. And so 3,600 seconds and 1 hour at the top. So the hours will cancel out. And then we have meters per second left. And then simply we do 4.5 multiplied by 0.3048 and then divided by 3,600, which gives us 3.81 times 10 to the minus 4 meters per second. In this example, we're asked to convert density from centimeters cubed per gram to meters cubed per kilogram. So the first consideration we need to make is how to convert from centimeters cubed to meters cubed. Well, we know that 1 centimeter is equal to 0.01 meters. Then 1 centimeter cubed will be equal to 0.01 meters all cubed. And that gives us 1 centimeter cubed being equivalent to 1 times 10 to the minus 6 meters cubed. And then, so that's us obtained our first unit conversion. And now the next conversion factor that we need to obtain is grams to kilograms. So we know that 1 gram is equal to 1 times 10 to the minus 3 kilograms. So those are our two conversion factors. Again, we start by writing 7.8 centimeters cubed per gram written as a fraction. Multiply that by, well, we'll try to get rid of our centimeters cubed and replace with meters cubed. So 1 times 10 to the minus 6 meters cubed divided by 1 centimeter cubed. And that will be multiplied by, again, we're trying to get rid of our grams here. So to get rid of our grams, we're going to have to multiply by grams at the top and then divide by 1 times 10 to the minus 3 kilograms. And then you'll see that our centimeters cubed rather, cancel out and our grams cancel out, and we're left with the units of meters cubed per kilogram. And again, we'll do 7.8 times 1 times 10 to the minus 6 divided by 1 times 10 to the minus 3, which gives us 7.8 times 10 to the minus 3 meters cubed per kilogram. In this example, we are asked to convert the universal gas constant from kilojoules per kilomole Kelvin to British thermal units per pound mole degree Rankine. And so we begin actually with our conversion factors for each of these units. So 1 kilojoule in terms of British thermal units, our 1 kilomole in terms of pound moles, and our 1 Kelvin in terms of degree Rankine. So we begin by writing our universal gas constant, 8.314 kilojoules per kilomole Kelvin. And again, I've written this out as a fraction to make our algebra a little bit easier. So now we're going to try to get rid of our kilojoule. So we're going to want to replace our kilojoule with 0.9478 British thermal units. Divide that by 1 kilojoule. So our kilojoules will cancel out and replaced with British thermal units. A similar thing for our kilomole. We want our kilomole to cancel out. So 1 kilomole divided by 2.205 pound moles. Again, our kilomole cancels out. And finally, multiply by 1 Kelvin divided by 1.8 degree Rankine. And our kelvins cancel out. Then we will do the calculation, 8.314 multiplied by 0.9478, divide by 2.205, and then divide by 1.8 as well. And that gives us a final value of 1.985 British thermal units per pound mole degree Rankine. In this question, we're asked to determine the gauge pressure in pound force per inch if we know our absolute pressure as 3.03 bar and our atmospheric pressure as 720 millimeters of mercury. So to determine our gauge pressure, we're going to use this equation shown. But what we will do is we'll actually go ahead and rearrange it for the gauge pressure. So our P gauge is going to be equal to our absolute pressure minus our atmospheric pressure. So that's the equation that we're trying to use. We need to be able to add and take away values, we need to make sure that they're in the same units. They must be consistent units. So we're going to convert all our values, our absolute pressure and our atmospheric pressure, into pound force per inch. So our absolute pressure, let's begin with our P absolute. So we have 3.03 bar, and we're trying to get rid of the bar and replace it with pound force per inch squared. So if you can see, we have actually a conversion factor which is almost made up of two equalities, and that's three separate. So 1 bar is equal to 14.5 pound force per inch squared, which is equal to 750 millimeters of mercury. So we're just concerned only with the bar and our pound force per inch squared, because this millimeters of mercury isn't relevant to determine the absolute pressure in pound force per inch squared. So what we're going to do is multiply by our 14.5 pound force per inch squared, and we're going to divide by our 1 bar. So our bar will cancel out, and then we're left with an absolute pressure of 43.935 pound force per inch squared. Okay, so we've done one. Now we have to also do the same for our atmosphere. So again, our atmospheric pressure is 720 millimeters of mercury. And so in this case, we're actually concerned about, we're not interested in our conversion factor of 1 bar. We are concerned only about the equality on the right. So we're going to multiply again by 14.5 pound force per inch squared, and we're going to divide by our 750 millimeters of mercury. Now, doing the calculation there, we obtain atmospheric pressure of 13.92 pound force per inch squared. Finally, our gauge pressure is then simply these two values minus one another, so 43.935 minus 13.92. I'll save the units until the very end, and that gives us a gauge pressure of 30.015 pound force per inch squared.